Hello everyone, today we are embarking on a journey 5,000 light-years into deep space to uncover one of the most breathtaking and mathematically flawless wonders the cosmos has ever produced. Kepler-11145123, the most perfect natural sphere ever observed by humanity. For centuries we have gazed at the stars, planets and moons above us, marveling at their round shapes that seem to define the order of the universe. We call Earth a blue marble, the Sun a blazing orb, and Jupiter a giant gaseous sphere. But the truth is, none of these celestial bodies are truly perfect. Every single one of them is stretched, squashed, or distorted by the unyielding forces of rotation and gravity. Yet, against all cosmic odds, there exists a star that defies this norm, a star so perfectly round that its very existence challenges the core principles of stellar physics we once took for granted. This is not a man-made precision instrument or a mathematical abstraction. It is a living, burning star, forged in the chaos of stellar birth, yet polished by the cosmos into a shape so pure it borders on the divine. To truly grasp the miracle of Kepler-11145123, we must first understand why almost nothing in space is a perfect sphere. Let us start with our home Earth. We learn in school that our planet is a sphere, but in reality, it is an oblate spheroid, a sphere slightly flattened at the poles and bulging at the equator. The difference between Earth's equatorial and polar radii is about 21 kilometers, a small gap created by the centrifugal force of our planet's 24-hour rotation. This bulge is so subtle that it is invisible to the naked eye from space, but it is measurable and undeniable. Now look to our Sun, the heart of our solar system. The Sun rotates once every 27 days slower than Earth, but its massive size means even this gentle spin creates a measurable equatorial bulge, roughly 10 kilometers between its equator and poles. Move outward to Jupiter, the solar system's largest planet, and the distortion becomes dramatic. Jupiter completes a rotation in just 10 hours, the fastest of any planet, and this furious spin stretches its equator so much that the radius difference jumps to nearly 9,000 kilometers. Even neutron stars, the densest objects in the universe, are pulled out of shape by their rapid rotations, some spinning hundreds of times per second, and warping into pronounced oblate spheroids. For decades, astronomers believed this pattern was universal. All celestial bodies rotate, all experience centrifugal force, and all are therefore imperfect spheres. That was the rule, until Kepler-11145123 shattered it completely. The story of this extraordinary star begins with NASA's Kepler Space Telescope, a mission designed to hunt for exoplanets by monitoring the tiny dips in starlight caused by planets passing in front of their host stars. Launched in 2009, Kepler stared at a single patch of the Milky Way for 4 years, collecting precise brightness data on hundreds of thousands of stars. Among these countless points of light was Kepler-11145123, a bright hot A-type star that initially drew no special attention. It was not a variable star with wild brightness swings, nor did it show signs of hosting large exoplanets. But a team of astronomers, led by Dr. Laurent Guizon, from the Max Planck Institute for Solar System Research and the University of Göttingen, had a different goal. They wanted to measure the shape of distant stars, a task once thought nearly impossible. For years, scientists could only measure the shape of a handful of nearby fast-rotating stars using optical interferometry, a technique that fails for faint, distant stars. Dr. Guizon's team turned to asteroseismology, the study of stellar oscillations, the tiny rhythmic pulses of light caused by sound waves bouncing around inside a star. These oscillations act like a cosmic stethoscope, letting astronomers peer into a star's interior and map its shape with unprecedented precision. For 4 full years, the Kepler telescope recorded every faint flicker of Kepler-11145123's light, capturing its natural oscillations as it expanded and contracted in a steady, gentle rhythm. The team analyzed these oscillations by comparing patterns from the star's equatorial regions and polar regions, a method that allowed them to calculate the difference between its equatorial and polar radii with an accuracy of just 1 kilometer. What they found left the entire astronomical community stunned. Kepler-11145123 has a mean radius of 1.5 million kilometers, more than twice the size of our Sunday. Yet, the difference between its equatorial radius and polar radius is a mere 3 kilometers. To put this mind-bending precision into perspective, imagine a giant ball, 100 meters wide. A 3-kilometer gap on a 1.5 million kilometer star is equivalent to that 100-meter ball having a bump of less than 0.2 millimeters, smaller than a grain of sand. This gives Kepler-11145123 an oblateness of just 1.3 parts per million, making it the roundest natural object ever measured, a title officially recognized by Guinness World Records. It is not just rounder than Earth, the Sun, or Jupiter. It is rounder than any other star, planet, or moon ever observed by human instruments. So, what makes this star so impossibly perfect? The answer lies in two key factors: its glacial rotation speed and its unique stellar physics. Most stars rotate at a pace that creates significant centrifugal force, which pushes mass outward toward the equator and flattens the poles. Our Sun spins once every 27 days. Jupiter spins once every 10 hours. Even many distant stars rotate every few days or weeks. Kepler-11145123, however, rotates once every 100 days, 3 times slower than the Sun, and so slow that the centrifugal force at its equator is almost non-existent. Without this force to stretch its shape, the star's own gravity pulls every atom into a state of perfect equilibrium, molding it into a near-perfect sphere. But the team's research revealed an even bigger surprise: the star's observed roundness is 3 times greater than even its slow rotation should produce. This led astronomers to hypothesize that Kepler-11145123 has a weak global magnetic field that helps stabilize its shape, along with a lack of the turbulent convective layers that distort many other stars. Unlike the Sun, which has a churning outer layer that creates sunspots and solar flares, Kepler-11145123 has a calm, uniform interior, free from the violent motions that would mar its perfect form. It is a star that exists in a state of cosmic tranquility, untouched by the chaos that shapes most other stellar bodies. The discovery of Kepler-11145123 is far more than just a fun cosmic curiosity. It is a groundbreaking breakthrough that reshapes our entire understanding of stellar structure and evolution. Before this star, our models of stellar shape relied heavily on rotation speed alone, but Kepler-11145123 proves that magnetic fields and internal structure play equally critical roles in determining a star's form. Asteroseismology, once a niche field, has now been proven as a powerful tool to measure distant stars with precision we never thought possible, opening new doors for studying stars thousands of light years away. For exoplanet hunters, this star is a game changer. Precise measurements of a host star's shape and size allow astronomers to calculate the size and orbit of exoplanets with far greater accuracy, bringing us closer to finding habitable worlds beyond our solar system. It also challenges us to rethink what normal looks like in the universe. We once assumed all stars follow the same rules of rotation and distortion, but Kepler-11145123 shows us that the cosmos is full of exceptions, of objects that break our models and force us to learn, adapt, and wonder. Think about the scale of this achievement for a moment. We are a civilization that only recently stepped beyond our own atmosphere, using telescopes built with human hands to study a star 5,000 light-years away, a distance so vast that light itself takes 5,000 years to cross it. We cannot visit this star, cannot land on it, cannot even see it as more than a tiny point of light. Yet, through the power of science, mathematics, and relentless curiosity, we have measured its shape to within a single kilometer, revealing a perfection that seems almost too beautiful to be real. Kepler-11145123 is a reminder that the universe is not just a place of violence and chaos, of supernovae, black holes, and colliding galaxies, but also a place of exquisite order, of mathematical beauty, of objects so perfectly formed they inspire awe in anyone who learns of them. It is a testament to the fact that even in the infinite darkness of space, symmetry and perfection can thrive hidden in plain sight among the countless stars. As we conclude our journey to this most perfect of cosmic spheres, let us carry with us a sense of wonder at the mysteries that still await us. For every strange and wonderful object we discover, from black holes that bend time to stars that are perfect spheres, there are millions more waiting to be found, each with its own story to tell, each challenging what we know about the universe we call home. Kepler-11145123 is not just a star. It is a symbol of the universe's infinite capacity to surprise us, to humble us, and to fill us with a lifelong passion for exploration. It tells us that no matter how much we learn, the cosmos will always have new secrets, to reveal new wonders to admire and new truths to uncover. Please like, comment, share, and subscribe to the channel.